Hi everyone, welcome to Vishwa Bloom. So in this video we'll be looking at optics, physics techno for class 8, concept 5 explanation. So concept 5 is completely about ray diagrams. So let's begin. So first, image formation due to spherical mirror. So how are the images going to be formed? That if we want to know the position of the image and the nature of the image formed due to the spherical mirrors, how do we find out? First is it depends on the distance of the object. So how far the object is kept from the image, so that matters here. And also, yeah, it depends upon the distance of the object from the mirror. That is the main cause, right? Now if we want to locate the position of the image, then there are two rays at least we have to know. Okay, two rays from the object at least we have to draw in order to locate the position. Okay, and we have to incident them. Two rays have to be incidented so that we can trace out the reflected ray. Now those rays also, we have ray rules. We will see that next. We are going to study that only, no need to worry. Okay, and the point of intersection of reflected rays, wherever both the reflected rays will intersect, that will give us the exact point of the image. Okay, so that is one point. And information about the image can be found out by two methods actually. One is by drawing this ray diagrams, which we are going to see in this concept, and other is by calculating using the formula which is there in the next concept. Okay, so this concept you are going to use only ray diagram. Next concept we will see this. Okay, yeah. So first we will see ray rules. Okay, so ray rules, there are four rules. Okay, totally four rules are there. Okay, so first rule I'll tell you for both concave and convex mirrors. Now I am considering a concave mirror first. Okay, this is the principal axis, pole, this is focus, and this is center of curvature. Now whenever I am drawing a ray through the center of curvature, it will strike back to the mirror normally, and it will reflect back through the same path. Suppose I have incidented one ray to I'll change the color. One second. Suppose I have incidented one ray to the center of curvature. Okay, I have sent one ray. Then it is going to come in the same direction. It is going to come back in the same direction. That's it. Okay. First rule you understood. Now let's see the same case for convex mirrors. Okay, so this is a convex mirror and this is the principal axis. This is the focus, center of curvature, pole. Okay, yeah, P. Now I'm going to change the color. Yeah, so now for this center of curvature you can't connect it directly because it is something virtual. Right, I told you they don't have real center of curvature and real focus is not present in convex mirror. So if a ray is passing like this, okay, if it is passing like this and backside it is getting extended and it is meeting the center of curvature, when it is incidented in such a way, it will get reflected also in same path. Okay, so this is for concave mirror, this is for convex mirror. This is the first rule. So what is the first rule? A ray through the center of curvature which strikes the mirror normally is reflected back along the same path. That is clear. Okay, I hope it is clear. Now let's see the ray rule 2 or rule 2 or ray 2, whatever it is. Okay, first let us have a concave mirror. Okay, and I will draw its pole, focus, center of curvature. Okay, yeah. Now what he is telling is I have a ray which is parallel to principal axis. Okay, then that ray after reflection it will actually or actually pass through the focus F. I will take other color, okay. Actually, I will change the color. So this is the incident ray. I have incidented it, okay. Arrow mark is very important. It is parallel to the principal axis, remember, okay. Then the reflected ray, whatever is there, no, it will pass through the focus. Sorry, 1 second. It will pass through the focus. That's all. That is what you have to remember it. When a ray is parallel to principal axis, the reflected ray it will pass through the focus. That's all. Okay. Now I will show for convex mirror. So this is a convex mirror. This is the principal axis. Okay, let the mirror be bigger. Like this. Yeah. And yeah, we are done. So this is the pole, this is focus, center of curvature, everything is done. Now here I am taking a ray which is parallel to the principal axis, okay. Yeah, and how it will get reflected? Like something like this. Now when I extend it backward, where it is meeting at? Yeah, so it is meeting at the focus, that's all. So same rule, we have drawn something parallel to, we have drawn a ray parallel to principal axis, then it is going to meet at the focus. That is the ray rule 2. Okay, I hope this is clear. This is for concave, this is for convex. Next we have ray rule 3. Okay, so first let us consider concave mirror. So here is a it's not neat, wait. Yes, here is a concave mirror and I have taken a principal axis here. This is pole, focus, center of curvature. So now when I am going to incident a ray from the focus, I am incidenting one ray from the focus. Now this ray will be parallel when it is reflected, no, it will be parallel to the principal axis. Just the ulta of the rule which we have seen, okay. Now when the ray is passed parallel, like from the focus, it will be parallel to the principal axis. Clear? Now let me show it for convex mirrors also. So this is a convex mirror. And this is the principal axis, pole, focus, here is focus, center of curvature. Okay, next we have an incident ray which is incidenting on focus. So we have to extend it backward, right? So suppose this is the incident ray and it is going to the focus roughly, because I can't show exactly, right? Yeah, imagine. Next that ray will be parallel to principal axis, parallel to principal axis. Clear? What is this mirror? This is concave mirror, this is convex mirrors. That's all. Next we will see the rule number 4, ray rule 4. So a ray striking at pole P is reflected symmetrically back in opposite direction. So first I will draw a concave mirror and a convex mirror. I'll draw its principal axis for both, pole, focus, center of curvature, pole, focus, center of curvature, and yeah. So what they have given is when and ray is striking through the pole only. See, a ray striking through the pole, it will get back in the same direction, it will get back in the opposite direction. See, now I am sending in this direction, no? See, again you see, from the pole I am ray is striking to the pole, at the pole. At the pole when the ray is striking, what happens? It will get reverse in opposite direction. That's it. See, from the pole it is going like this, means it will come back in the opposite direction. Nothing to remember. Okay, this is for concave mirror, convex mirror. So I hope rules are clear to you. And yeah, next we have to see image formation for both concave and convex mirrors. First we will see for concave mirror. So there are totally number of cases are totally 6 cases we have, okay, for concave. So let's begin. So now we'll begin the ray diagrams for concave mirror. So image formation due to concave mirror, case 1. So when the object is at infinity is the first case which we are going to look at it, okay. When the object is at infinity, so I have written few statements already because it will be easy for us, right? So we can complete it quickly. So first, as we all know that we are supposed to take at least 2 points. You all know, right? So from infinity I am taking, right? So infinity is somewhere here out of the principal axis. Am I right? Somewhere here, out of the line. So from there, if I am taking one ray parallel to the principal axis and other ray also I am taking parallel to the principal axis, okay. How it is going to meet? It is going to meet at the focus according to the ray rules, okay. So it is going to meet at the focus, right? This also is going to meet at the focus. So you all understood this part, right? So it is meeting at one single point called as focus. So now, what is the nature of the image? Now let's learn about the image characters which is formed in this particular case. So image character, so image is going to be real because it is formed in the reflected part of the mirror. See, this is the part is reflected part and this is the silvered part, right? So if it is formed in the reflecting part, it is a real image. So nature of the image is real, okay. Write that. So you can write it as image is real. And see, image, it is going to be ulta, okay. Image is like ulta because when I'm sending one ray from pole, it will become ulta. So image is inverted. When, see, remember one thing, when the image is real, no, it will be inverted, okay. Whenever it is in the reflecting side only, then the image will be ulta, inverted, like this. If the object is like this, then the image will be like this, ulta, okay. So I hope that is clear to you. Now let's look at the size, how much big it is, how much small it is. See, it is very, very small. See, this point sized it is. So you can write it as highly diminished. We use the terminology highly diminished in order to say if it is very, very small or point sized. So you can also use point sized in bracket. Okay. Now where it is focused, if it is at infinity, it is focused at focus only. The image is formed at focus. So this is first case. Now we will see the second case. So here when object is beyond the center of curvature is the second case. Object, actually we are supposed to remove this at. I'll just put beyond. Object beyond center of curvature. Okay, here beyond means. Okay, now I'll use multiple colors so that you will be clear with the concept. So I am placing here, let this be the object which is beyond C, center of curvature. Now first I am going to send one ray parallel to the principal axis to the mirror. Okay, this is the ray. It is obviously going to come from the focus. So it came here, right? Yeah, let me draw it even more straight. Okay. Next, what I have is I am going to send a ray from center of curvature with other color. Okay. Yeah, let me choose this color. With center of curvature, I'm going to send one ray. Yeah, like this exactly. Yeah. So in this direction only I'm sending, and in that direction only it will go back. Okay, so now you see that this is the here is the point of intersection, so there only image is formed actually. Okay, yeah, so this is the image, like this it will be formed ulta. Okay, so again let's write the nature and size by looking at the picture here. So now first image, is it real or an virtual? Obviously it is real because it is towards the reflecting surface only, so nature is real. Next we have this is inverted, right? So image is inverted, you can see clearly in this case it is towards double down, right? So you can simply write it as inverted. Okay, now size. Now see, object is this much big, image is this much very small, right, as compared to the image. So you can say it is little small, so diminished you can use, not highly diminished, right, diminished. Okay, next we have where it is located. It is located between the center of curvature and focus. Between it is there, no, we'll just write it as it is. Actually you should not use the terminology at, let's say between. Okay, so let's say between what it is located, C and F, center of curvature and focus. Okay, I hope this is clear to you all. Let's see the case 3. So case 3 we have object at center of curvature. Before we had beyond, now exactly on the center of curvature we are going to have the object. So yeah, this is the object at, okay, at center of curvature. Now first we are going to send one ray from this parallel to principal axis. So we will get a reflected ray from the focus. You all know this. And next I'm going to send one ray like I'm going to send it through the focus. From this I'm going to send through the focus. That means what? The reflected ray will come parallel to principal axis. Now where is the image formed? Where is the image formed? Think of it. Here both the both the reflected rays are meeting. Or else I'll show with different colors so that you will get to know where the reflected rays are getting connected. So let me take green. This is the reflected ray. Again I'm taking red and I'm passing a ray through the focus, and it will get reflected from the to parallel to the, what to tell, principal axis. So where is the reflected ray meeting? Here, right? Both the reflected rays. Now green are the reflected rays. It's very clear for you now, right? So where is it formed? Here. So now I took exact rays. So here you can see exactly below the center of curvature it is formed. Okay. I'll draw only one ray exactly below the center of curvature. See, if you draw with correct appropriate measurements, see if you draw this mirror with compass and take the scales exactly, like from pole to focus, if you take 2 centimeter and focus to center also, if you take 2 centimeter, exact results you will get, and if you draw all this rays with scale and pencil, then you will get appropriate results. Exactly, you will be able to see the correct result on your page. Okay, so you can try that. Now I can't show that on the screen obviously. So let me tell the nature of the image. So as it is towards the reflecting surface, it is a real image. So if the image is real, obviously it is inverted, and also you can see it in the image that the image is inverted. And next, image size. So how it is, the sizes are same, almost the same as the object. So just same as object, size is same as object. Okay, sorry. Next we have where it is located. It is exactly formed at the center of curvature only. At center of curvature only it is formed. So when object is at C, it is, the image also is at C. Okay, Let's move on to the fourth and one important case only. Like all cases are important. Anyway, we have the object between, let me write that. We have the object between center of curvature and focus. First we had beyond the center of curvature, then we had exactly at center of curvature. Now we're going to have between center of curvature and focus. Okay, yeah. So let me take the object here exactly in between them. Yeah, let this to be the object. Now I am going to take the incident rays with red color. Okay, so I am drawing a line parallel to the mirror and parallel to the principal axis. Then it is obviously going to come from the focus. Okay, come from the focus, and again I am going to draw another ray from this point, that is, or reflected rays. I told I'll draw with green, right? Let me draw with green. Okay. Yeah, perfect. 1 second. Oh my god, these rays are not coming properly. Yeah, now let's take another ray which is going to be passing from the focus, and obviously when it is passing from the focus it is going to be parallel, parallel to principal axis, right? So here goes the reflected ray, parallel. Yeah, so both are reflected in such a way, and here is the point of intersection of both the reflected rays. So now I'll draw the image. So image, where it is coming, I'll draw it correctly. So the image, it is formed beyond the center of curvature, right? Somewhere over here, beyond it is formed. So let's write the nature. So nature, yeah, obviously it's a real one, and it is, if it is real, obviously it is inverted, and the size, as you can see, it is enlarged. It's actually quite bigger than what we have drawn. So enlarged, and then it is at no, it is formed beyond. So let's just change this terminology to beyond C. Okay, so let's look at the fifth case. Okay, now in fifth case we have an object which is exactly at the focus. Okay, so before starting with it, I'll tell you one thing. One more ray rule is actually not given in your book, but it is actually very much important. That rule number 5. Okay, it is there in your 10th standard, but it is not there here. Okay, see, when a ray is drawn to the pole, exactly to the pole, no, from one side, then it is going to reflect with the same angle. Sorry, ulta direction, like this. Okay, suppose this is 60 degree, you have drawn one line to the pole, then same 60 degree you will get. That rule is actually missing. They didn't give, but we need to use that rule only here. Don't know why why they have not given. Okay, fifth case. So when the object is at principal focus, so exactly here when the object is. Okay, now let me draw incident ray. First I'm going to incident one ray which is parallel to the principal axis, and yeah, it is obviously going to go from the focus, and I have another ray which is going to pass from the pole. Okay, see, I have taken that rule. Okay, obviously that will come like this. Now see one thing, if I extend them also too much, I'm not going to get a point where they will meet. They are never going to meet. Okay, so uh, yeah, but even though if it is towards the reflecting surface, the nature is going to be real, and if like if the nature of image is real, and it is going to be inverted, the image. And size, if I talk about, it is going to be very big, because see, if it goes on, right? So it is going to be very, very big. So I can say it as highly enlarged. Highly enlarged. And where it is formed? It is formed at infinity. We don't know the exact position. Okay, so this is case 5, and next we have case 6. When we have an object between focus and principal pole. Okay, so how do we do that? Now first the object, let me draw it here, is going to be here, and first I'll draw a parallel ray parallel to principal axis. Let me draw the arrow markers bit smaller. Yeah, this is the object, and I'm going to draw some parallel ray, and it is obviously going to reflect through the focus in this way, something like this. Okay, yeah, like this. Okay, and then I'm going to take one more incidenting line from the pole, like in this angle. Yeah, that is going to reflect at the same angle like this, right? Yeah. Okay, done. Now where do the points are going to meet? Obviously these points will never meet. See, in case 5 there is a chance of for them to meet, even though they are parallel, somewhere we can meet them, but here they are going in two different directions, right? One is going this way, one is going that way. They can never ever meet, right? So here what is going to happen? What are we going to do? We're going to extend the rays backward in order to find out the image. That means we are not going to get a real image, but we are imagining one image. So from where do we extend it? Actually from the reflected rays, okay? From here like this, yeah. Okay, so it is going to be very big actually. So somewhere over here you will find the image. So image is very big. Yeah, so size I can write it as magnified or highly enlarged. Magnified I'm going to use. Highly enlarged is image which is very, you cannot never imagine that size. Okay, so I'm going to write magnified or enlarged, whatever it is. Okay, the image is virtual because it is towards the silvered side of the mirror, and obviously it is erect because you can see that, right? It is same as the object, like direction. When the image is virtual, remember it is erect, or you can say it as upright. Okay, and obviously where it is at exactly, it is behind, it is behind the mirror. So you can write behind the mirror. So these are all the ray diagrams for concave mirror. Then we have for convex too. But before moving, let's see one observation point. So one observation is there actually. You should have observed it. See, first we had image here, object at infinity. Then the image was at focus here. Remember this point. Then we moved the object little bit forward and we put it beyond C. And then we got the image where between C and F. Okay, image went backward. Before it was at focus, now it went back. Okay. Then in case 3, we moved the object even more forward and put it on the center of curvature. Then the image, it also went back. Right, when it was like in case 2, it was between C and F, and then later on it went exactly beyond C. So when I moved this object here, when I moved it, image also came backward. When when object is moved forward, image is coming backward. Again, I moved even more forward from center of curvature. I sent it to between center of curvature and focus. I moved it even more nearer to the mirror. Then the image came beyond C, even more back it went. Then I sent the image to focus. That means I moved even more nearer to the image, and then I got image at infinity. So By seeing the 5 cases, what do you observe? Only for 5 cases. Do for 5 cases, don't consider the 6th one. Okay. So by seeing these 5 cases, we can conclude one observation. What is that? We can observe that as the object moves forward, moves towards the mirror, moves forward in the sense towards the mirror, the object, what it is doing, it is moving away from the, as the object moves towards the mirror, image, what it is doing, it is, image moves away from the mirror, away from the mirror. I hope you understood this observation point. Okay, yes. So let's move on to convex mirror. So let's see first how many cases are there to study for ray diagrams of convex mirror. There are just 2. So let's learn. Now we'll see case 1 of the for ray diagrams of convex mirror. First we have object when it is placed at infinity. Okay. So from infinity they are going to be infinite rays coming, right? So I am going to take few rays. It is going to be parallel to principal axis. Okay. One more ray also let me take. Yeah. So now I'm going to extend this. So where it is meeting at? It is meeting at focus, and the reflected ray, where it is at focus. So let's write the characteristics which are obtained here. So nature is here, right? It is virtual image. It is because it is towards us, like it is back of the mirror. So it is virtual. So when an image is virtual, it is going to be straight. That is erect or upright, you can say. Or upright. Anything you can write. I do not have space, so I'm erasing upright. Now size is highly diminished. See, it is exactly at the point of focus, right? So it is highly diminished. So just write that. Okay. Next, where it is formed at principal focus. I'll just write it. You just write full thing. Next, case 2 is when we have an object at finite point. So finite point I wrote, but in the textbook it is like between pole and infinity. It means that it is in a finite point, right? So that's what I have mentioned. Okay. So now this is the object. Now I'm going to take a ray parallel to this. It is going to get reflected in this way. And one more point I'm going to take to the pole, and obviously this way it is going to come back. Am I right? Now I'm going to extend them backward because I cannot meet them anyway. Right. So let me do so here. Okay. Now this one will go this like this. Let me extend it. 1 second. Yeah. And the other reflected ray will go like this to the focus. So where did it meet? It met here, and this is the image. Okay, so it's very small, actually very small image, but it is formed behind the mirror, so the nature is virtual. Sorry. So when it is virtual, obviously it is erect, and you can also see in the on the screen, right? Size is high, like not highly diminished but diminished. Highly diminished is point size. So this is diminished, we can say. And where it is between the pole and focus. So P and F. Done. So we are done with the cases. Now last part what we have is some note points. Okay. So first point is that concave mirror is converging and convex mirror is diverging. So that is what we have to see in the note points. Like, share and click the bell icon, and don't forget to subscribe to our channel. Bye bye.